Hello everyone. So this video presentation is the continuation of the previous video. As I have discussed in the previous video, topics on what is embedded system, embedded versus general computing system, history of embedded system. So further in this video I will discuss on the topics on classification of embedded systems and the major application areas of embedded systems. So coming to the classification of embedded system, so the embedded systems are classified as based on generation, based on complexity and performance requirements. Now coming to the based on generation, so the embedded systems classified as the first generation, second generation, third generation and fourth generation. Now coming to the first generation embedded systems, so in the first generation embedded system, the early embedded systems were built around 8-bit microprocessor like 8085 and 4-bit microprocessor. So these embedded systems are simple in hardware circuits with software developed in assembly code. And the example for these generations are digital keypads and stepper motors. Now coming to the second generation, so these are the embedded systems built around 16-bit microprocessor and 8 or 16-bit microprocessors. The instruction set for second generations are more complex and powerful compared with the first generation. And example for these generations are data acquisition system and SCADA systems here. Now coming to the third generation, so these are embedded systems built around 32-bit microprocessor and 16-bit microcontrollers. And in this generation, a new concept of application and domain specific controllers like digital signal processors and application specific integrated circuits are introduced in this generation. And the instruction set of processors became more complex and powerful, and the concept of pipelining. So remember this point. So the concept of pipelining is introduced in this generation. And embedded systems spread into areas of robotics, media, then industrial process control and computer networking and many more areas. And coming to the fourth generation, the fourth generation embedded systems are making use of high performance real-time embedded operating systems for their functioning, and smartphone devices, mobile internet devices, etc. are the example for the fourth generation embedded systems here. Now coming to the next classification, that is based on complexity and performance requirements. So according to this classification, embedded systems can be grouped into the small scale embedded system, medium scale embedded system, large scale embedded systems, or they can be called as the complex systems. So these classification is done based on complexity and performance requirements. So as we can see in the small scale embedded systems, the complexity is less and the performance requirements are less. Then coming to the medium scale embedded systems, so they are slightly complexity and performance requirement is medium. And in the large scale embedded systems, the complexity is more and performance requirement is more here. Now coming to the small scale embedded systems. So these embedded systems which are simple in application needs and the performance parameter are not time crucials. As I said, these small scale embedded systems, they are less complexity and the performance requirement is not that much critical here. So examples like electronic toys, then micro ovens, washing machines and air conditioners are example for the small scale embedded systems here. And they are built around a low performance and low cost 8 or 16-bit microprocessor or microcontroller here. And mostly small scale embedded systems come with limited resource like amount of memory and processing power, and can be programmed in assembly level languages here. Now going to the medium scale embedded systems. So these systems which are slightly complex in hardware and software, and medium scale embedded systems are usually built around medium performance, low cost 16 or 32-bit microprocessor or microcontroller here, or digital signal processors. So they usually contain an embedded operating system. So here in these medium scale embedded systems, we require the operating systems. And example for medium scale embedded systems are missile guidance systems, aircraft navigation systems. Now coming to the large scale embedded systems or the complex systems. So the complexity is more, then performance requirement is higher. So embedded systems which involve highly complex hardware and software. So firmware are called as a software here. They are employed in mission critical applications demanding high performance, and the large scale embedded systems are commonly built around high performance 32 or 64-bit RISC processors here or microcontrollers. Then they are usually contain high performance real time operating systems for task scheduling, prioritization, and management here. Okay, so this is all what the classification of the embedded systems. So two classification based on a generation and based on the complexity and performance parameters here. Now going to the another next topic, that is major applications areas of embedded systems. So these embedded systems play a vital role in our day-to-day life, starting from home to computer industry. As you can see that the embedded systems are used in home also, like as we have seen the washing machines, air conditions, they are all come under the embedded systems here. And embedded technology has acquired a new dimension from its first generation, so that is the Apollo guidance computer, and to the latest radio navigation system combined with in-car entertainment technology and variable computing devices like Apple Watch, Microsoft Band, Fitbit, fitness trackers, and etc. And the application areas and the products in the embedded domains are countless. So they are used everywhere. So a few of the important domains and products are listed below here. So the application areas of embedded systems, like they are used in consumer electronics. So embedded systems, that is camcorders, cameras, they are embedded systems. Then embedded systems are used in household applications as a television, DVD players, washing machine, fridge, micro oven, etc. And embedded systems are used in home automation and security systems like air conditioners, sprinklers, intruder detection alarms. So intruder detection alarms are nothing but if an unwanted person enters into a in your house, then so these intruder detection alarms will are used to detect the unwanted person so who is entering into the home here. Then closed circuit television cameras, fire alarms, etc. Then embedded systems in automotive industries like anti-lock braking systems ABS, which are used in the car, then engine control, ignition systems, then automotive navigation systems, etc. Then embedded systems are used in telecommunications like cellular telephones, telephone switches, handset multimedia applications, etc. Embedded systems are used in computer peripherals, they are used in printers, scanners, fax machines, etc. And embedded systems are used in computer networking systems, so they are used in the network routers, switches, hub, firewalls, etc. Then embedded system in healthcare, a different kind of scanners, then EEG, then ECG machines, etc. are of embedded systems. Then embedded systems in measurement and instrumentation, like digital multimeters, digital CROs, then logic analyzer, PLC systems, etc. Embedded systems in banking and retail, that is automated teller machines, ATMs. So these are machines which are used to withdraw the money, right? And the currency counters and the point of sales. Then embedded systems in card readers, that is barcodes, smart card readers, handheld devices, etc. Then embedded devices in wearable devices, that is health and fitness trackers. They are used in gyms. Then smartphone screen extension for notification, and in many more. Then finally in the cloud computing and Internet of Things. So Internet of Things, this is the important area where the embedded systems are used here. So at the end of the video, what we can conclude is that I have covered the topics on classification of embedded systems, so which are based on generation, like first generation, second generation, third generation, and fourth generation. Then the classification of embedded system based on complexity and high performance requirements, like the small scale, then medium scale, then large scale or complex. Then finally, I covered the application areas of embedded systems. So thank you for watching this video. I hope so this video help you to understand the things. Okay. So if you are having any doubts or you need clarification, so you can post in the Moodle. Thank you.